Hi there! Welcome to Akilimo. Akilimo is a service that can teach you how to grow your cassava in a smart way. That is why we say, we know cassava. In this video, we will teach you all about cassava maize intercropping and how to use our printable guide in 6 easy steps. In these 6 steps, you will learn 1. Which cassava variety to plant. 2. Which maize variety to plant. 3. At which density to plant maize. 4. How to evaluate if fertilizer is profitable. 5. When and how much fertilizer to apply. And 6. How to apply fertilizer correctly. To obtain a good recommendation, you need to provide some information. You need to know 1. Your land area. 2. How your maize would perform without fertilizer. 3. The price of urea and NPK 15 to 15 to 15 fertilizers. 4. Whether you will sell fresh maize cobs or dry grain. 5. The price of your maize produce. And 6. Your risk attitude. You will learn about how to use the Akilimo guide on cassava maize intercropping and the accompanying farmer's worksheet. Let's get started. Step 1. Plant the right cassava variety. Plant a disease-tolerant erect variety like TME 419 or TMS 98 or 581. We recommend obtaining disease-free cuttings from an accredited source. Plant your cassava in rows that are 1 meter apart and plant cuttings at 0.8 meters within the row. That gives a density of 5,000 cassava plants per acre. If your field is ridged, plant your cassava on the crest of the ridge. This information is also summarized in the farmer's worksheet. Plant a disease-tolerant, erect variety like TME 419 or TMS 98 or 0581. Plant your cassava at 1 meter between rows and 80 centimeters within row. Next is step 2. Plant the right maize variety. Plant an early maturing maize variety that full matures in 90 to 95 days like Samaz 35, a yellow maize variety, or Samaz 48, a white variety. Ask your local agro-dealer or extension agent for advice on the best variety in your area. Plant your maize in rows that are 1 meter apart between the rows of cassava. If your field is ridged, plant your maize mid-slope. This information is also summarized in the farmer's worksheet. Plant a short duration variety that matures in 90 days, for example, Samaz 35 or Samaz 48. At this point, the farmer's worksheet also requests you to specify the area of your field in acres. This is box A. The field area will be used in the cost-benefit analysis under step 4. As an example, let's assume the area of the field is 1.5 acre. We now continue with step 3. Plant your maize at the right density. The best density depends on the fertility of the soil. To estimate the fertility of your soil, we look at how your crop performs. You need to know how your maize would look like at testling if you grow it without fertilizer. You need to choose 1 out of 5 options. Would it be 1. About knee-high with yellowish leaves. 2. Between knee and chest height with yellowish leaves. 3. Taller than a person, that is taller than 200 centimeters with yellowish leaves. 4. Taller than a person with somewhat green leaves. Or 5. Taller than a person with deep green leaves. If it is the first option, which is quite rare and found in very poor and degraded soils, then your soil is very poor. You need to improve soil fertility before considering investing in fertilizer. You should apply compost or manure or fallow for at least 2 years. Plant maize at a low density of 8,000 plants per acre. Sow maize seeds at 50 centimeters within rows. Poor soils do not support planting maize at high density. When you plant too many seeds, the plants will compete for the little nutrients that the soil can provide, and all maize plants will yield small cobs. By sowing fewer maize seeds, you will have fewer plants, but each plant can have a larger cob. If it is the last option, which is also an uncommon situation only found in recently cleared forest fallows and heavily fertilized fields, then your soil is very fertile. It is likely that your maize yield will not improve much after fertilizer application, so there is no need to invest in fertilizer. Plant maize at a high density of 16,000 plants per acre. Sow maize seeds at 25 centimeters within rows. Since your soil is very fertile, it can support more plants. By sowing twice as many seeds, you will get a higher yield and there will be sufficient nutrients for all plants to develop large cobs. If it is number 2, 3 or 4, the intermediate situation, then you need to evaluate if fertilizer application is profitable. We will do this later in step 4. If you decide not to apply fertilizer, then plant maize at low density and sow maize seeds at 50 centimeters within rows. As in the first situation, your soil will not be able to support a high number of maize plants, and you better plant at low density to have fewer plants but with well-developed cobs. If you decide to apply fertilizer, then you can plant your maize at high density and sow maize seeds at 25 centimeters within rows. To make sure that you have the right number of plants in your field, we recommend planting 1 seed per hill and gap missing plants at 3 to 5 days after planting. Alternatively, you can plant 2 seeds per hill and thin to 1 plant per hill after 1 to 2 weeks. Let's look at how step 3 is explained in the farmer's worksheet. For step 3, you use your knowledge of how maize would grow without fertilizer. How would your maize crop look like at tasseling? Is your maize less than 50 centimeters tall, like the maize plant under option 1? Then your soil is very poor. Apply manure. Do not invest in fertilizer. Plant at 1 meter by 50 centimeters. If not, does your maize look like number 5? Is it deep green and more than 200 centimeters tall? Then your soil is very fertile. Do not invest in fertilizer. Plant maize at 1 meter by 25 centimeters. If not, then your maize looks like number 2, 3 or 4. Your maize crop can benefit from a fertilizer investment. Do a cost-benefit analysis in step 4. If you decide to apply fertilizer, plant maize at 1 meter by 25 centimeters. Else, plant maize at 1 meter by 50 centimeters. The worksheet provides the expected yield response for your maize crop. If your maize is less than 150 centimeters tall and yellow, that is number 2, you can expect an additional 2,600 large cobs per acre. If maize is taller than 150 centimeters and yellow, that is number 3, you can expect an additional 1,600 large cobs per acre. If maize is taller than 150 centimeters and greenish, that is number 4, you can expect an additional 1,000 large cobs per acre. This is box B. Your selected answer will be used in the cost-benefit calculations in step 4. As an example, let's assume number 3. We think maize would be taller than 150 centimeters and yellow in our field. Then we can expect an additional 1,600 large cobs per acre in our field. Let's now proceed to step 4 and do a cost-benefit analysis. We will evaluate profitability by comparing the price of the maize produce against the cost of the fertilizer. First, you need to decide if you will sell your maize as fresh cobs, then follow instructions under A, or as dry grain, then follow instructions under B. So option A is for selling your maize as fresh cobs, while option B is for selling your maize as dry grain. Let's first look at option A. That's when maize is sold as fresh cobs. The first diagram in the row is used to evaluate the fertilizer response of a maize crop that looks like maize plant number 2. The second diagram in the row is to evaluate the fertilizer response of a maize crop that looks like maize plant number 3. The third diagram in the row is to evaluate the fertilizer response of a maize crop that looks like maize plant number 4. In the second row, you find the same diagrams to evaluate fertilizer response for option B when you sell your maize as dry grain. Let's, for our example, assume that we will sell our maize as fresh cobs. And remember, in our example, we selected number 3 for how we expect our maize to look like at tasting. Let's now look closely at this diagram to learn how to evaluate profitability. On the vertical axis, you need to select the row according to the price you expect to receive for one large fresh cob. For example, let's choose 50 naira for one large fresh cob. On the horizontal axis, we need to choose the row according to the cost of fertilizer. This requires a small calculation. First, you need the price of a 50 kg bag of urea. Let's take an example of 6,000 naira. Next, you need the price of one 50 kg bag of NPK 15 to 15 to 15. Let's assume a bag of NPK costs 7,200 naira. Now calculate the cost of one bag of urea and 2.5 bags of NPK. 6,000 plus 2.5 times 7,200 equals 24,000 naira. Now look at the diagram and find the vertical row of 50 naira as the price of one large fresh cob. Then find 55 in the horizontal row of cost of 2 bags urea plus 6 bags of NPK. We are not showing the 3 zeros because of lack of space. The units on the horizontal axis are given in thousands of naira. The color of the box where the 2 arrows meet is green. Now look at the legend. The green color means that fertilizer is very likely profitable. So you can go ahead and invest in fertilizer. But what happens if the maize price drops to 30 naira? Now the 2 arrows meet in the brown box. This means that fertilizer may still be profitable, but you have a major risk of losing money. You now need to decide if you still want to invest in fertilizer. We have now done the cost-benefit analysis using the Akilimo guide. But we can do this in more detail using the Farmer's Worksheet. The Farmer's Worksheet takes you through the steps to do the cost-benefit analysis. We first need to provide some information. In box C, enter the price of a 50 kg bag of urea. Then, provide the price of a 50 kg bag of NPK 15 to 15 to 15 in box D, and the expected sale price of one large fresh maize cob in box E. As with our example in the Akilimo guide, let's assume a price of 6,000 naira for one bag of urea, 7,200 naira for one bag of NPK, and an expected sale price of 50 naira for one large maize cob. Now we are ready to do the calculations. We will take you through these calculations step by step. It's important to practice this so that you learn how to do this yourself for your own field. By understanding costs and benefits, you will be able to make the best decision on investments in your cassava maize intercrop. First, we will calculate the increase in production. This is the extra number of maize cobs that you can expect to produce in your field due to fertilizer application. The middle column provides the calculation to perform. You must multiply the value in box A with the value in box B. Box A contains the area of your field. Remember, in our example, this was 1.5 acres. The expected fertilizer response is 1,600 cobs per acre. This was entered earlier in box B. To calculate the increase in production, we multiply A by B. 1.5 times 1,600 equals 2,400. We now know that we can expect an additional 2,400 cobs in our field of 1.5 acre when we apply fertilizer. We note this result in box A. Let's move on to the next row. Now we will calculate the increase in gross revenue. Essentially, this is the value in naira of the extra 2,400 cobs harvested in the field. We need to multiply values H and E. We need the increase in production calculated in box H and the expected sale price of one large fresh maize cob. This was entered earlier in box E. To calculate the increase in gross revenue, we multiply H by E. 2,400 times 50 equals 120,000. We note the result of 120,000 naira in box I. We now know that the extra production due to fertilizer application has a value of 120,000 naira. Let's move to the next row. Now, we will calculate the quantity of urea to apply on our field of 1.5 acre. We need to multiply value A by 50. We again need the area of our field in acre in box A. The amount of urea needed for 1 acre is 1 bag of 50 kg. So, we need to multiply 1.5 by 50. This equals 75. We need to apply 75 kg of urea in our field of 1.5 acre. We note the result of 75 kg in box J. Let's move to the next row. In the same way, we will calculate the quantity of NPK to apply. We again need the area of our field in acre in box A. The amount of NPK needed for 1 acre is 2.5 bags or 125 kilograms. So, we need to multiply 1.5 by 125. This equals 187.5. We can round 187.5 to 188. We need to apply 188 kg of NPK in our field of 1.5 acre. We note the result of 188 kg in box K. Now, we will calculate the cost of urea. We need the quantity of urea from box J. We had calculated that we need to apply 75 kg of urea. Next, we need the price for 1 bag of urea. This was entered earlier in box C. To calculate the cost of urea, we divide 6,000, the price for 1 bag of urea, by 50, the weight of 1 bag of urea, to obtain the price of 1 kilogram of urea, and then multiply by 75, the quantity of urea in kilogram to be applied. This equals 9,000. We now know that the cost of the urea to apply is 9,000 naira. We note the result of 9,000 naira in box L. Let's move to the next row. In the same way, we will calculate the cost of NPK. We need the quantity of NPK from box K and the price for 1 bag of NPK from box D. To calculate the cost of urea, we divide 7,200, the price for 1 bag of NPK, by 50, the weight of 1 bag of NPK, to obtain the price of 1 kilogram of NPK, and then multiply by 188, the quantity of NPK in kilogram to be applied. This equals 27,000. We can round 2772 to 27,000. We now know that the cost of the NPK to apply is 27,000 naira. We note the result of 27,000 naira as cost of NPK in box M. Let's move to the next row. Now, we can calculate the total cost of the fertilizer to apply. We simply need to add up the cost of urea and the cost of NPK. We need the cost of urea from box L. This was 9,000 naira. And we need the cost of NPK from box M. This was 27,000 naira. We can now sum these up to calculate the total cost. 9,000 plus 27,000 equals 36,000. The total cost of fertilizer is 36,000 naira. We note the result of 36,000 in box N. Let's move to the final row. Lastly, we will calculate the profit from fertilizer use. We need the increase in gross revenue from box I. This was 120,000 naira. And we need the total cost of fertilizer from box N. This was 36,000 naira. We can now calculate the profit from fertilizer as 120,000 minus 36,000. This equals 84,000. Our expected profit from fertilizer is 84,000 naira. We note 84,000 naira as profit from fertilizer in box O. The cost-benefit analysis is now complete. To make a decision, we need to evaluate if fertilizer use is profitable. Let's look at the results again. What is the expected increase in gross revenue? This is 120,000 naira in our example. It is the value of the additional 2,400 cobs we expect to produce due to fertilizer use. And what is the total cost of fertilizer? That is 36,000 naira in our example. It is combined cost of the urea and NPK fertilizer we need to apply. So what is the expected profit from fertilizer? The difference is 84,000 naira. This is the extra money we expect to make due to our investment in fertilizer. But this value is an estimation. It may be smaller or larger depending on how you manage your crop, depending on the weather in the upcoming season, and depending on the price of maize at the time of harvest. Whether this expected profit is large enough depends on your risk appetite. Your risk appetite means to what extent you can afford to make investments and like to take risks. To get an idea of this, consider how often you currently invest in new farm products or technologies. Have you perhaps tried out new herbicide products? Or invested in new farm implements? Or perhaps purchased seeds of a new crop variety? Farmers who invest often in new products or technologies like taking risks, and this usually means that they can afford to make investments that do not pay off. The other way around, farmers who do not invest often need to be more sure about how profitable an investment needs to be before they decide to go ahead. So the lower your risk appetite, the larger the expected profit margin must be to justify an investment in fertilizer. The Akilimo tools consider three possible answers: very rarely, sometimes, and often. If you answer very rarely, then this means you do not like taking risks. You would therefore only invest if your expected profit is very large compared to the cost you need to incur. We recommend you only invest in fertilizer if your expected gross value increase is at least 3 times larger than the total cost of fertilizer. For every naira invested, you expect to get at least 3 naira in return. If your answer is sometimes, then you accept some risks. You have a medium risk appetite. You would therefore only invest if your expected profit is quite larger than the cost you need to incur. We recommend you only invest in fertilizer if your expected gross value increase is at least twice as large as the total cost of fertilizer. For every naira invested, you expect to get at least 2 naira in return. If you answer often, that means you like taking risks. You can afford to invest even if you are not very certain it will pay off. You would therefore only invest if your expected profit is somewhat larger than the cost you need to incur. We recommend you only invest in fertilizer if your expected gross value increase is at least 1.2 times larger than the total cost of fertilizer. For every naira invested, you expect to get at least 1.2 naira in return. Let's go back to our example. 3 times the cost is 3 times 36,000 or 108,000. This is still smaller than 120,000. So fertilizer use is recommended even if you are very risk averse. The farmer's worksheet guides you through this calculation as well. Let's go back to the table with calculations. There is one additional row we need to complete. We need to calculate the benefit cost ratio. This will help you decide if your expected profit is large enough to justify investing in fertilizer. We need to divide value I by value N. Value I is the increase in gross revenue, 120,000 naira. And value N is the total cost of fertilizer, 36,000 naira. 120,000 divided by 36,000 equals about 3.3. We note this value down in the table. A value of 3.3 is very good. This means that for every naira invested in fertilizer, you can expect to get more than 3 naira in return. In the worksheet, we show how to use the benefit cost ratio to make a decision on fertilizer investment. The worksheet allows you to select your risk appetite by asking you again how often you invest in new farm products or technologies. If you don't like taking risks and you rarely invest in new products or technologies, your benefit cost ratio should be at least 2.8 or rounded 3. The value in our example is 3.3, which exceeds 2.8. This means that fertilizer is highly profitable, and Akilimo recommends to invest even if you don't like taking risks. It is a safe investment in your situation. We now move to step 5. Apply fertilizer at the right time. The Akilimo guide provides the fertilizer rate for 1 acre of a cassava maize intercrop. We recommend applying 42 kg nitrogen, 8 kg phosphorus, and 15 kg potassium per acre. This equals 2.5 bags of 50 kg of NPK 15 to 15 to 15 and 1 bag of 50 kg of urea for 1 acre. You need to apply all the NPK at planting, then half of urea at 3 weeks after planting, and the other half of urea at 5 weeks after planting. By spreading the application of fertilizer, you apply nutrients in the fertilizer at the time that your maize crop needs them most, and you avoid that rainfall washes the fertilizer away before your crop can use them. Let's now look how you convert these rates to the situation of your field. We will again use our example of a field of 1.5 acre. So we multiply 1.5 by 125. This equals 188 kg of NPK that need to be applied at planting. 188 kg is about 4 bags of NPK. So, on 1 acre, you would apply 2.5 bags of NPK at planting. On 1.5 acre, you need to apply 4 bags of NPK at planting. You now know you need to purchase 4 bags of NPK. Let's look at urea. For 1 hectare, you need to apply 50 kg, that is 1 bag at 3 weeks after planting, and another bag of urea at 5 weeks after planting. Now how will that look like for our field of 1.5 acre? We multiply 1.5 by 50. This equals 75 kg and is the total amount of urea to be applied to the field. 75 kg equals 1.5 bags. You can distribute the fertilizer over the 2 splits, but better is to apply half a bag of urea at 3 weeks after planting and a full bag of urea at 5 weeks after planting. It is better to apply the larger amount of fertilizer when the plant is taller and can take up more fertilizer. Let's look at how step 5 is explained in the farmer's worksheet. Apply NPK fertilizer at planting. Apply half of the urea at 3 weeks after planting. Apply the other half at 5 weeks after planting. Remember, fertilizer requirements have already been calculated under step 4. The quantities to apply were calculated as part of the cost-benefit analysis. The quantity of urea has been calculated in box J. We need to apply 75 kg of urea. This equals 1.5 bags of urea. The quantity of NPK has been calculated in box K. We need to apply 188 kg of NPK. This equals about 4 bags of NPK 15 to 15 to 15. We can now proceed to the final step. Step 6. Apply fertilizer in the right way. For 1 acre, we apply 2.5 bags of NPK at planting, half a bag of urea at 3 weeks after planting, and half a bag of urea at 5 weeks after planting. Step 6 provides information on how to apply this fertilizer best. To apply the NPK at planting, make a hole 5 cm away from the maize seed. If you plant on ridges, make the hole on the upper side. The hole should be about 5 cm deep. Spread the NPK equally in each hole, then cover the soil. To apply the urea at 3 weeks after planting, make a shallow furrow about 10 cm away from the maize hills. If you plant on ridges, make the furrow on the upper side. Spread the urea evenly and cover with soil. Apply the urea at 5 weeks after planting in the same way as the urea at 3 weeks after planting. Fertilizer should only be applied when the soil is moist. The moisture in the soil will dissolve the fertilizer granules and release the nutrients contained so that the plant roots can take these up. Only then can your crop benefit. This is also summarized in Step 6 on the farmer's worksheet. Only apply fertilizer if the soil is moist. Apply NPK in holes and urea in furrows at 5 and 10 centimeters away from the maize seed. Cover fertilizer with soil. A final remark: fertilizer will also increase your cassava root yield by at least 2 tons per hectare. We did not include this in the cost-benefit analysis, but you can expect extra revenue from your cassava crop as well when investing in fertilizer. So what have we learned? Let's summarize the 6 steps. 1. Plant the right cassava variety. Plant a disease-tolerant erect variety like TME 419 or TMS 98 or 581. Plant your cassava at 1 meter between rows and 80 centimeters within row. 2. Plant the right maize variety. Plant a short duration variety that matures in 90 days. For example, plant Samaz 35 or Samaz 48. 3. Plant maize at the right density. Plant your maize at 1 meter by 25 centimeters if your soil is very fertile or if you apply fertilizer. A high maize density is only sensible if soil nutrient levels are high. Else, plant your maize at 1 meter by 50 centimeters. 4. Do a cost-benefit analysis. Evaluate the profitability of fertilizer use. Use your knowledge of how maize would perform without fertilizer, the price of fertilizer, and the expected maize produce price to calculate the profit expected from fertilizer before deciding to invest. 5. Apply the right amount of fertilizer at the right time. Per acre, apply 2.5 bags of NPK at planting, half bag of urea at 3 weeks, and another half bag of urea at 5 weeks after planting. Part B. Per acre, apply 6 bags of NPK at planting, 1 bag of urea at 3 weeks, and another bag of urea at 5 weeks after planting. And lastly, 6. Apply fertilizer in the right way. Apply fertilizer in holes or furrows close to the maize hill. Only apply fertilizer if the soil is moist. That's it. These are the 6 steps on how to intercrop cassava and maize. Now you know all about cassava-maize intercropping and how to use our printable guide in 6 easy steps. We hope you enjoyed this video. Thank you so much for watching. Akilimo, we know cassava.